Welcome. The Passive Sampling Technology Update team is proud to present an overview of the Nylon-Screen Passive Diffusion Sampler technology. This quick video will provide a high-level overview of the device, as well as instructions on how to use, deploy, and retrieve the device. For more information on this and other passive sampling technologies, please visit the Passive Sampling Technology Update Guidance document. The Nylon-Screen Passive Diffusion Sampler, or NSPDS, is a diffusion-based equilibrium-type passive sampler used to sample a wide range of chemicals in groundwater, surface water, and pore water. The technology was originally developed to sample for trace metals in groundwater. Since then, it has been used to sample volatile organic compounds, major cation and anions, dissolved oxygen, total organic carbon, 1,4-dioxane, and perchlorate. During deployment, target chemicals in surrounding aqueous media diffuse through the nylon screen and equilibrate with water filled inside the sampler. NSPDS are retrieved after a sufficient deployment duration, which can be influenced by the surrounding aqueous environment, target chemicals, bottle size, aspect ratio, and nylon screen mesh size. Because a fully constructed NSPDS is not commercially available, the sampler must be constructed by users. NSPDSs operate using the principles of molecular diffusion across the nylon mesh screen from the aqueous media to the interior of the sampler filled with deionized water. A concentration gradient exists between the chemicals in the target aqueous media and the interior of the NSPDS bottle. Chemicals tend to migrate from the area of high concentration to an area of low concentration until dynamic equilibrium is achieved. The rate at which equilibrium is attained is determined by several factors, including the magnitude of the concentration gradient across the nylon mesh screen, the ratio of the sampler volume and surface area of the nylon screen, the pore size and thickness of the mesh, and the diffusion coefficient of the tested chemicals. A fully assembled NSPDS is not commercially available, but the individual materials can be purchased, and the device can be constructed by the user. The main parts of the NSPDS are a wide-mouth bottle constructed of polypropylene or glass, filled with analyte-free deionized water, a 125 to 250 micrometer nylon screen mesh, and a bottle cap with opening. The required sample volume and target chemicals will impact the bottle material, volume of the bottle, and the pore size of the nylon screen mesh. A single sample bottle can be deployed, or sample bottles can be stacked in a polypropylene mesh bag for groundwater and surface water sampling. For sediment pore water sampling, a more rigid PVC cap is typically used to keep the integrity of the nylon screen mesh during deployment and retrieval. NSPDSs need to be filled with deoxygenated reagent water if redox-sensitive chemicals are to be collected. If dissolved oxygen is present, trace metals will be present in the sample and bias results. The units are assembled in water that is purged of dissolved oxygen by sparging with nitrogen for at least 1 hour. When assembled, air bubbles should not be trapped inside the bottles. The assembled samplers can be transported to the field either in buckets containing a nitrogen atmosphere or kept immersed in deionized water. The samplers should be assembled and transported to the field with minimum handling of the samplers on site. The samplers also must be kept cool and avoid oxygen until they are deployed. Different mouth sizes of bottles correspond to different ratios of the volume of sample, or V, per the surface area of the nylon screen mesh, or A, shown here. The sampler on the left has a VA ratio of 6:1 with a plastic cap, which is typically used for ground or surface water sampling. The sampler on the right has a VA ratio of 22:1, with a protective PVC cap for sediment pore water sampling. For deployment into water, follow the following steps. Measure the depth to groundwater, then based on the well screen interval and the targeted sampling depth, and adjust the length of the suspension line. Attach to the top of the protective plastic mesh with a cable tie or equivalent. A weight can be inside the plastic mesh or attached, and secured outside of the plastic mesh. When ready for deployment, remove the NSPDS from the transport container, and immediately place the sample bottles into sampling media, minimizing exposure to the atmosphere. It is preferable to deploy the samplers sideways in a well. If sideways is not feasible, deploy it facing downward to minimize mixing as the samplers are brought back to the surface. Carefully place the sampler into target sampling media at a desired location and depth. Ensure your NSPDS assembly is secured to a firm point on land if deploying to surface water. When deploying the sampler into sediment, use the following procedures. Measure the water depth, if applicable, to properly document site conditions, and to determine the approximate depth from water surface that the device will be positioned. Secure each sampling device tightly with one or more nylon zip ties, so that the zip ties will not slip off of the device. Attach a nylon fishing line to one or more of the zip ties and affix a brightly colored fishing bobber at the other end of the fishing line. Ensure the fishing line is long enough to be suspended, and allow the bobber to float above the device's location once buried in sediment. Dig a hole deep enough to bury the sampler approximately 8 inches into the sediment. Place the samplers on their sides to decrease the danger of puncturing the mesh during insertion and retrieval. When retrieving the device from water, here are some steps to keep in mind. After an appropriate deployment duration, gently retrieve the sampler from the sampling media. Any residue on the sampler during deployment should be removed with analyte-free reagent water and wipe clean. Then, remove the lid and nylon screen of each sampler, and immediately transfer the water sample into the laboratory-provided bottles. A second option is to use solid caps over the membrane in place of the open caps, especially if no preservative is necessary. The retrieved samples can be placed on ice and shipped to the laboratory for analysis. When retrieving the device from sediment, here are some steps to keep in mind. After an appropriate deployment duration, gently retrieve the sampler from the sediment. Remove any solid buildup on the sampler during deployment with analyte-free reagent water and wiped clean. Then, collect the water samples by using a disposable syringe, hypodermic needle, and a 45-micron filter unit, mounted between the syringe and hypodermic. Thrust the sharp tip of the hypodermic through the nylon mesh to extract the sample for transfer into the laboratory sampling jars. The filled sample bottles can be sent to the laboratory on ice for analysis. Some of the advantages of the Nylon-Screen passive diffusion sampler include: they can sample a diverse range of organic and inorganic chemicals. The device can sample at discrete intervals in aqueous media to vertically profile a monitoring well or identify contaminant stratification. The bottles can be stacked to increase sample volume, or to sample an entire screen length in a monitoring well. Some limitations include: the samplers are not commercially available, but can be constructed using materials from vendors. Sample volume is a concern if sampling for a wide range of chemicals. These samplers are better suited for large-diameter groundwater wells. Sampling for certain metals should be approached with caution due to redox potential. Some important considerations about the NSPDS device. Deployment duration should be carefully determined for your target analytes. Extended periods of deployment may be needed to achieve equilibration for certain metals. The samplers must be filled with deoxygenated water, without headspace in the bottle, and kept from the atmosphere until deployment. The recovered sample water may require filtration through a 0.45 filter, if dissolved concentrations are desired. For more information on the NSPDS and other passive sampling technologies, check out the ITRC Passive Sampling Update web guidance.